A particle p is moving on the x-axis and its velocity v in positive x direction is given by the particle is passing through the origin when t is 0. Determine the displacement of the particle from the origin when it has covered the total distance of 13 meters. First of all, what is the difference between displacement and distance? Displacement in general is a vector which connects the starting point and the end point. It may be positive or negative, and if it's one-dimensional motion, as for this problem, displacement from the origin, it just coordinate of a particle, and a distance or distance traveled or total distance traveled, it's total length of the path covered by a particle regardless of direction, or we can say that it's a length of its trajectory. And using integration, displacement from t1 to t2, it's an integral of velocity dt, and distance, it's from t1 to t2, it's an integral of the absolute value of velocity dt. And it will be very useful to illustrate this motion with the graph, velocity against time graph, and using a calculator. And in general, you can see that it's a quadratic function. Why? Because t squared is present and coefficient in front of t squared is positive, so it's a concave parabola. And the usual function window, let it be xb from 0 to 8, yb from -2 to 10, and the graph, and you can see that it's a concave parabola, and we need x-intercepts or zeros. These points, you may get them directly from a calculator or using a formula for roots with discriminant, and it looks like this. This is 2 and this point is 4, and it's very important that at t is 2 and t is 4, a particle is instantaneously at rest. It means that it changes direction, and from t0 to t2, velocity is positive. It means that a particle is moving to the right, and if you calculate an integral from 0 to 2, v dt, it's a formula for displacement, and you will get that it's positive, and let's calculate it. So integral from 0 to 2 is 10/3 and plus meters. And if you calculate integral from 2 to 4, v dt, it's also displacement, you get that it's negative. Why? Because you can see that velocity is negative, and it means that the particle is moving to the left, and using a calculator, you can see that it's -2/3. Let's illustrate it. So there is an origin, so it moves 10/3 to the right, then 2/3 to the left. And you can see that displacement is plus 10/3 minus 2/3, so displacement is 8/3, and if you calculate integral from 0 to 4 v dt, you get 8/3 meters. But if you calculate integral from 0 to 4, the absolute value of the velocity dt, you get 10/3 plus 2/3, it's 12/3 or 4 meters, and you get total distance traveled. And we need total distance traveled to be 13, so additionally it is required 9 meters, and from t is 4, it is moving to the right only, so to the right, so it is required additionally 9 meters. So eventually you can see that it has covered, or total distance traveled is 13 meters as required. And what about displacement? Displacement is plus 10/3 minus 2/3 and plus 9, and it's 8/3 plus 9. 9 is 27 over 3, so it's 35 over 3 meters, and you can see that it's positive. So eventually it will be to the right from the origin. And it's the required displacement. And that's all for this problem.